In our next set of problems from the solutions packet, we look at acid-base titrations. A titration typically uses a solution of known concentration and known volume to determine the concentration of an unknown solution. In the first problem, we're asked to determine the concentration of sodium hydroxide, but we know that a known concentration of hydrochloric acid can be used to neutralize this solution. So we should begin with the equation representing the neutralization of sodium hydroxide and hydrochloric acid, which can be given by this equation. And a quick analysis of the information that's given to us and what we're asked to find shows that we have the known volume of each substance, and we have the concentration of hydrogen chloride, so we could use this to determine the concentration of sodium hydroxide. Now, a word on these problems, there are actually several different ways to solve them, but what I see is that the number of moles of hydrochloric acid and the number of moles of sodium hydroxide are going to be the same because they're at a 1-to-1 ratio in the equation. So, therefore, we can just determine the number of moles of sodium hydroxide needed and the volume of sodium hydroxide. And in this problem, I added an extra factor to show you the 1-to-1 ratio of sodium hydroxide to hydrogen chloride. So I begin with the number of moles of hydrogen chloride in that sample is equal to the molarity of hydrogen chloride times the volume of hydrogen chloride. Then I multiply it by the stoichiometric ratio, which again is 1-to-1. So on the top of the equation, I have the total number of moles of sodium hydroxide. I divide it by the volume of sodium hydroxide, 0.025 liters, to determine the total molarity of the sodium hydroxide solution, which is 0.217 molar sodium hydroxide. Now, again, if you are using the idea that the number of moles of sodium hydroxide and the number of moles of hydrochloric acid are the same, you could set this up in several different ways and still get the same answer. In the next problem, we have a known concentration of hydrochloric solution, and we want to know what volume would be needed to neutralize each of the bases, sodium hydroxide and barium hydroxide, both strong bases. So let's look at letter A. We have hydrochloric acid reacting with sodium hydroxide to create sodium chloride and water. And I see that this is going to be hydrogen chloride and sodium hydroxide in a 1-to-1 ratio. So I began by finding the number of moles of hydrogen chloride necessary. That's 0.3 moles per liter of sodium hydroxide, and the volume is 0.010 liters. And then I use the mole ratio of hydrogen chloride to sodium hydroxide, and I determined that it needs 3 times 10 to the minus third moles of hydrogen chloride or hydrochloric acid. And I can substitute that into the molarity equation. Solving for volume, volume is equal to the number of moles over the molar concentration. So I have 3.00 times 10 to the minus third moles of hydrochloric acid, and its concentration is 0.500 moles per liter. So that gives me a volume of 6 milliliters, and that's 6 milliliters of hydrochloric acid to neutralize the amount of sodium hydroxide in problem A. We set up problem B the same way with a reaction to start with. This reaction I'm noticing is not balanced. This should be a 1-to-2 ratio of barium hydroxide to hydrogen chloride. So I'm going to write in a 2 there to make this balanced. And that will create 1 barium chloride and 2 waters. So substituting in, my concentration times my volume will give the number of moles of barium hydroxide. And then I multiply it by the stoichiometric ratio, 2 moles of hydrochloric acid to 1 mole of barium hydroxide. And this time I get 4 times 10 to the minus third moles of hydrochloric acid are needed to neutralize that solution. So just like we did in the last one, we're looking for the volume. That is the number of moles divided by the molar concentration. So we use 4 times 10 to the minus third moles of hydrochloric acid divided by the volume of hydrochloric acid, and that gives us a quantity of 4.00 milliliters.